Hello to all viewers. I welcome students of class 11 and desire that they go through the contents posted herewith in my channel, which deals with questions and answers from the Unit 1, some basic concepts of chemistry of class 11. The contents are as per NCERT textbook Part 1, which is followed by CBSE and other state boards. The contents would also serve as recap for class 12 students. I would be posting more of these types of questions in my next presentation. I would like to mention that our team comprises of Parshuram Bellari sir, who's an IT expert with vast experience in the field of computer science and at present pursuing PhD at Triple IT Dharwad, and KG Sujaya, that's me, retired KV principal from Wayanad, settled in Kannur district of Kerala with 24 years of teaching experience as chemistry teacher and 10 years as principal in various Kendra Vidyalayas in India, and at present author of the contents of this channel. Our duo's focus would be to acclimatize students in the adoption of problem solving approach to make the study of chemistry easier, meaningful and enjoyable. Now, coming to the quiz question which was asked in the second video, what was phosphine was asked. Phosphine is the flashing or simmering light that you see when gently pressing your eyes with your knuckles, with your closed eyes with your knuckles. These are visual sensations of light that occur without actually light entering our eyes. It is due to the mechanical stimulation of the retina causing the optic nerve to send signals to the brain that are interpreted as light. So that's the answer. So now let's begin with the presentation of questions and answers from the unit, some basic concepts of chemistry. Question 1. A crystalline solid comprises of three elements X, Y, Z, and the number of moles of each element are 0.998, zero point 0.5 and 1.995 respectively. If the ratio between its molar mass and empirical formula mass is unity, that's 1, unity is 1, deduce the molecular formula of the compound. So this problem essentially deals with determination of molecular formula of a compound, for which first and foremost you have to find out the empirical formula of the compound. Empirical formula is the simplest whole number ratio between atoms of various elements present in one molecule of the compound. But molecular formula shows the actual number of atoms of various elements present in a molecule of the compound. So, first we would be ascertaining the simplest whole number ratio, that is empirical formula, for which we tabulate the given data. The first column consists of elements X, Y, Z. The second column is number of moles. Already it is given in the problem. You don't have mass given, weight of X, Y and Z given, their atomic mass given. So there is no need for you to determine the number of moles, mass by molar mass. It is not necessary. In this problem, number of moles is already given of X, Y, Z. 0.998, 0.5, and that of Z is 1.995. Now, among these three, the smallest number of moles is 0.5. So you know, to find out the molar ratio, we divide the number of moles by the smallest number of moles. That would be the third column, molar ratio. So the molar ratio is calculated as 0.998 by 0.5, 0.5 by 0.5, that of Y, and Z is 1.995 by 0.5. That comes out to be equal to 1.996, and 0.5 by 0.5, 1.995 by 0.5 is 3.99, approximating, because these are all experiments. So 1.996 is taken as 2 and 3.99 is taken as 4. So empirical formula of the compound would be X2YZ4. So first step is over. Now it is given in the problem that the ratio of molar mass to the empirical formula mass of X, Y, and Z elements compound, that is given to be equal to unity, that is 1. That means in this problem, N is equal to 1. What is N? Molecular formula mass by empirical formula mass. That is equal to N, and that N is equal to 1. Hence, molecular formula of the compound is its empirical formula into N, which is 1. N is 1 here. Therefore, molecular formula would be the same as its empirical formula, X2YZ4. Question number 2. In an experiment, 17 grams of ammonia react with 32 grams of oxygen at 800 Kelvin, and the reaction is represented by the equation 4NH3 gas plus 5O2 gas gives 4NO gas plus 6H2O gas. Identify the limiting reactant and the number of moles of the other reactant left in excess. So there are two parts to this problem. First, calculation of limiting reactant, identifying it, and then calculating the number of moles of the other reactant which is left in excess. This problem is an application of stoichiometric equation, numericals based on stoichiometric equations. Stoichiometric equation is a balanced chemical equation. The reaction here is between ammonia gas and oxygen gas. It's an oxidation reaction. 4 molecules of ammonia react with 5 molecules of oxygen gas to form 4 molecules of nitric oxide gas and 6 molecules of water. Here, the first part of this problem is, since mass of ammonia and oxygen gas taken are given, we need to calculate the number of moles of both the reactants, ammonia and oxygen. So, number of moles of ammonia would be its mass 17 by its molar mass. Now, what's a molar mass of ammonia? 17. So, mass in grams 17 divided by its molar mass in grams per mole, 17 grams per mole. So, the number of moles of ammonia gas taken is 1 mole. Next, same way we calculate the number of moles of oxygen gas, which is the other reactant. That is, mass of oxygen gas is 32 divided by its molar mass, which again is 32. So the number of moles of oxygen gas taken for this reaction is also 1 mole. According to the stoichiometric equation given, 5 moles of oxygen require 4 moles of ammonia for the reaction to occur. Once again, 5 moles of oxygen gas need 4 moles of ammonia for the reaction to take place. Therefore, 1 mole of oxygen, which is the number of moles of oxygen we have taken for the experiment. Therefore, 1 mole of oxygen would need what number of moles of ammonia? That is equal to 4 into 1 divided by 5, which is 0.8 mole. You calculate it and find it to be equal to 0.8 mole of ammonia. But in the experiment, the number of moles of ammonia taken is 1. We need only 0.8, but number of moles of ammonia gas taken is 1. Therefore, it is very clear that ammonia gas is taken in excess. Ammonia gas is taken in excess. How much of it would be left behind? 1 minus 0.8. 0.8 only is required for the reaction. So how much would be remaining in the reaction chamber? 0.2 moles of ammonia. Now, in this case, since ammonia gas is taken in excess, the other reactant, oxygen gas, is the limiting reactant. What is a limiting reactant? That reactant which gets completely consumed when a reaction goes to completion, almost completion, is known as the limiting reactant. Once again, that reactant which is completely consumed when a reaction goes to completion is called as the limiting reactant. And it is this limiting reactant's concentration, that is number of moles, which will determine the number of moles of products formed. The limiting reactant determines the quantity of the products formed. Question number 3. An aqueous solution of glucose is labeled as 20% W by W. W by W means weight percent. You can also call it as mass percent or weight percent. So it's 20% W by W. If the density of the solution is 1.2 gram per ml, calculate its molality and mole fraction. Now, this problem deals with reactions carried out in solutions and their concentrations. Many of the chemical reactions carried out in the lab are in solutions. Suppose you have a binary solution. A binary solution will consist of a solute dissolved in a given solvent. Here, our solute is glucose and the solvent water, aqueous solution. So the solvent is water. So there are various ways to express the concentration of the solute in the solvent. How much of solute is present in a given volume of the solvent or in a given mass of the solvent. These different ways of expressing concentrations, you can express them in mass percent, mole fraction, molarity and also molality. If you know these, for the time being, it is more than enough. How to calculate them? So, in the problem, it is asked molarity. We need to use the data given 20% W by W. What does it mean? 20% W by W of glucose, or M by M, mass by M by M of glucose means that 20 grams of glucose is present in 100 grams of the solution. 20 grams of glucose is dissolved in 100 grams of the solution, and we know that the molar mass of glucose is 180 gram per mole. You can calculate glucose C6H12O6, so that is 180 gram per mole. Therefore, first step would be to calculate number of moles of glucose and therefore molarity of the solution. Number of moles of glucose, you know to calculate number of moles. Mass by molar mass. Mass of glucose given is 20. So 20 by its molar mass 180, which is equal to 0.1111 mole of glucose. Volume of the solution. How to calculate volume of the solution? Total mass of the solution is 100 grams. 20 grams of glucose present in 100 grams of solution. In the problem, density is given. So, mass of the solution by its density will give us the volume of the solution. And the volume of the solution works out to be 100 by 1.2, 83.33 ml. You can convert it into liters divided by 1000 ml or cc divided by 1000. You will get the volume of the solution containing 20 grams of glucose in liters. Therefore, molarity of solution is equal to number of moles of solute present in volume of what is the volume of the solution in liters. Number of moles of solute divided by volume of solution in liters. Directly you substitute the different the mole and the volume. So moles you have calculated, moles of glucose 0.1111 divided by 83.33 divided by 1000. So 1000 will come to the numerator. Therefore, we get 0.1111 into 1000 by 83.33, which is 1.333 molar. So that's the molarity of the solution of glucose, 20% W by W glucose solution. Now, to calculate molality, molality is defined as the number of moles of solute in 1 kilogram of the solvent. Here, what is the number of moles of the solute? Number of moles we have calculated 0.1111 mole. Now, mass of the solvent in kilogram. We know the mass of the solution, which is 100 grams. From the mass of the solution, on subtracting mass of the solute dissolved, that is 20 grams, we get mass of the solvent to be equal to 80 grams. Therefore, express the mass of the solvent in kilograms. So that would be divided by 1000. Hence, molality of the solution is 0.1111 divided by 80 by 1000. So 1000 will once again come to the numerator and you get 0.1111 into 1000 divided by 80, which is 1.389 molal. So that's the molality of the solution, 1.389 molal. MOLAL. Then third, the last one is calculation of mole fraction. Mole fraction of any component is equal to the number of moles of that component divided by total number of moles in the solution. Here you are asked to calculate mole fraction of glucose. So what is mole fraction of glucose? Number of moles of glucose divided by total number of moles in solution. What is the number of moles of total number of moles to calculate? We need the number of moles of water. Number of moles of water is its mass, 80 grams, divided by its molar mass. Molar mass of water is 18. So 80 by 18 is 4.444. Therefore, total number of moles in the solution is number of moles of water plus number of moles of glucose. Number of moles of glucose we calculated in the beginning itself. Add them, we get total number of moles present in the solution is 4.555. Hence, mole fraction of glucose is equal to number of moles of the solute, which is glucose, divided by total number of moles in the solution, which is 4.555. So, mole fraction of glucose is 0.1111 divided by 4.555, which is equal to 0.0244. So that's the mole fraction of glucose. Question number 4. What is the change in molarity of a solution when its temperature is increased from 298 Kelvin to 333 Kelvin? So this question deals with the effect of increase of temperature on the molarity of a solution. We know the mathematical expression for molarity. M is equal to number of moles of solute divided by volume of solution in liters. It is a known fact that as temperature increases, volume of a liquid also increases. Therefore, the volume of the solution would increase when the temperature rises. If we look at the mathematical expression, the volume term is in the denominator. Greater the denominator, greater the volume, lower will be the molarity of the solution. Therefore, molarity would decrease on rise of temperature, on increasing the temperature from 298 Kelvin to 3, or any increase in temperature. Coming to question 5. The mass of 1 by 12th 6 carbon 12 is the same as that of dash. Choose two correct options. 1 by 12th of 6 carbon 12. 6 carbon 12 is the most stable isotope of carbon. Now look at the options. A. 1 by 8th of mass of neon. B. 1 by 8th of mass of oxygen molecule. C. 1 mu. D. 1 by 38th of the mass of fluorine molecule. What would be the answer? The mass of 1 by 12th of 6 carbon 12 is the same as that of 1 mu. 1 mu is called as unified mass. Earlier, we used the term AMU, atomic mass unit, 1 atomic mass unit, or 38 atomic mass unit, or 19 atomic mass unit. But now it has been replaced by mu, unified mass. So 1 mu is equal to 1 by 12th of the mass of 6 carbon 12. The other option D, let us consider. On calculating the molar mass of F2, that is the atomic masses of two fluorine atoms, 19 plus 19, which is 38 mu. Therefore, 1 by 38th of 38 mu is equal to 1 mu. Hence, 1 mu and 1 by 38th of mass of fluorine molecule will be exactly equal to 1 by 12th of the mass of 6 carbon 12. So the correct options are C and D. Question number 6. The molecular formula of a hydrocarbon is CaHb. To undergo complete combustion, it requires 9 times its own volume of oxygen and results in the production of 7 times its own volume of carbon dioxide. That sentence is important. To undergo complete, once again I'm repeating, to undergo complete combustion of what? Of that hydrocarbon, it requires 9 times its own volume of oxygen and results in the production of 7 times its own volume of carbon dioxide. What is the molecular formula of the hydrocarbon? Hydrocarbons are carbon and hydrogen containing organic compounds. Only such organic compounds will contain only carbon and hydrogen. Okay, once again this problem is based on stoichiometric equation. Now, the general equation for a combustion reaction of any hydrocarbon can be given by the equation. This is a standard equation. CXHY, that means the number of carbon atoms is X, number of hydrogen atoms is Y. So CXHY plus X plus Y by 4 O2, these many moles of O2 gas is required for the combustion of CXHY to give what? X moles of CO2 plus Y by 2 moles of H2O in the gaseous state. This equation I have taken from your textbook, NCERT textbook. You can refer. I have given the page number also there. So, the hydrocarbon general equation is CXHY, but the hydrocarbon given in our problem is CaHb. Therefore, we will modify the equation for combustion reaction as CaHb plus A plus B by 4 O2 gives ACO2 plus B by 2 H2O. Instead of X, I substituted A. Instead of Y, I substituted B. That's all. So that is our stoichiometric equation. As per this equation, 1 mole of CaHb requires A plus B by 4 moles of oxygen to form A moles of carbon dioxide and B by 2 moles of water in the gaseous state, because it's a combustion reaction. Instead of talking in terms of moles, we can also give the same stoichiometric equation in terms of volumes of reacting gases and products. Therefore, we say 1 volume of CaHb requires A plus B by 4 volumes of oxygen and forms A volumes of carbon dioxide and B by 2 volumes of H2O in the gaseous state. Now, we have to make a supposition here. Supposing if the volume of CaHb is V liters, So volume of CaHB taken as V, supposed as V liters. Then as per the given data, volume of carbon dioxide gas is 7 times the volume of the hydrocarbon taken. In other words, what is the volume of carbon dioxide as per the stoichiometric equation? A into V. A into V. That is equal to 7 times V, because the volume of carbon dioxide gas is 7 times the volume of the hydrocarbon. So we have formed the equation AV is equal to 7V. Cancelling V we get, or A is equal to 7. Now, it is given in the problem that the hydrocarbon requires 9 times its own volume of oxygen. The hydrocarbon requires 9 times its own volume of oxygen. According to the stoichiometric equation, what is the volume of oxygen? A plus B by 4 into V. That is equal to 9V. Cancelling V on both sides, simplifying, we get A plus B by 4 is equal to 9. Substituting the value of A as 7, we get A 7 plus B by 4 is equal to 9, or 28 plus B the whole divided by 4 is 9, or 28 plus B is 36, hence B is 36 minus 28, which is 8. Therefore, A is equal to 7 and B is equal to 8. Therefore, the formula of the hydrocarbon would be the C7H8. CaHB is now represented as C7H8. Question 7a. What is meant by NTP and STP? Answer to that is STP and NTP are two standard sets of conditions of temperature and pressure for experimental measurements involving gases and liquids. They are two standard sets of conditions. You have to maintain certain standards. We use either NTP or STP. STP stands for Standard Temperature and Pressure. Standard temperature is 0 degrees Celsius or 273 Kelvin. Standard pressure is 1 atmosphere or 1 bar or 101.325 kilopascal or 101,325 pascal. Pressure, you can express it in any of these forms. Coming to normal temperature and pressure, NTP. Pressure is the same as in case of STP, 1 atmosphere or 1 bar or 101.325 kilopascal, etc. But temperature is 20 degrees Celsius or 293 Kelvin. Here we have to note that there is often in the problems it would be mentioned that the experiment is carried out at room temperature. Room temperature can vary from 20 it vary between in the range 20 degrees Celsius to 25 degrees Celsius or 293 Kelvin to 298 Kelvin. In such cases, room temperature in most of the cases would be specified. The temperature would be often mentioned in the problem. So, you should know the difference between normal temperature and pressure and standard temperature and pressure. Coming to question 7b. Suppose if the atomic mass of the element carbon would have been 60 mu instead of 12. It is now 60 mu. What would be the value of Avogadro number? Avogadro number, Na. It is shown as Na. I suppose you know what is Avogadro number. Avogadro number, Na, is the number of atoms or molecules present in 1 mole of the compound taken. 1 mole of the compound taken, and that number has been calculated to be equal to 6.022 into 10 power 23. In fact, this Avogadro constant, it's called as Avogadro constant, Na. It is the largest constant which we use in chemistry. Okay, coming to this problem. If atomic mass of carbon is assumed to be 60 mu, then the Avogadro number Na would be equal to the number of carbon atoms in 60 grams of carbon. We know that 12 grams of carbon contain, that is 12 grams of carbon is 1 mole of carbon. 1 mole of carbon is 1 gram atomic mass of carbon. 1 gram atomic mass of carbon, 12 grams, is equal to 1 mole of carbon. So 12 grams of carbon contains 6.022 into 10 power 23 atoms of carbon. Therefore, 60 grams of carbon would contain how many atoms of carbon? We have to multiply 6.022 into 10 power 23 into 60, the whole divided by 12. That comes out to be equal to 30.11 into 10 power 23. Shifting the decimal, we can write it as 3.011 into 10 power 24 atoms of carbon. So Avogadro number Na would be 3.011 into 10 power 24 if the atomic mass of carbon is 60 mu. Question number 8. Two statements, one assertion and the other reason are given, which pertain to the law of definite proportions. Law of definite proportions is otherwise called as law of constant composition. From the options given, you have to choose the correct option. What is the assertion statement? The law of definite proportions holds good for all types of pure compounds. Reason: a pure chemical compound always contains the same elements combined together in the same definite proportion by mass. Assertion and reason are given. Options are both assertion and reason are correct, and reason is the correct explanation of assertion. B. Both assertion and reason are correct, but reason is not the correct explanation of assertion. C. Assertion is correct, but reason is incorrect. D. Assertion is incorrect, but reason is correct. Here, this statement, the law of definite proportion, holds good for all types of pure compounds, given as assertion, is a wrong statement. Whereas reason, the statement given is correct. So, option D would be correct. Assertion is incorrect, but reason is correct. Now, why is this assertion statement incorrect? Why law of definite proportion does not hold good for all types of pure compounds? This is because when a compound contains different isotopes of an element, the elements are same, but their atomic masses are different, then law of definite proportion fails in such cases. For instance, carbon dioxide, when it is formed from C12, that is atomic mass of carbon is 12, C12, it's called as carbon 12 isotope, and O16, atomic mass of oxygen is 16, carbon 12, oxygen 16. The ratio between them would be 12 is to 32 in carbon dioxide. One carbon atom, two oxygen atoms. So 12 is to 32. If you simplify it, it comes to be equal to 3 is to 8. That's the ratio. But if carbon dioxide is formed from C14 isotope of carbon, atomic mass of carbon 14 in this isotope, and O16, oxygen is 16 as before, then the ratio between carbon and oxygen would be 14 is to 32 in carbon dioxide, which is on simplification we get as 7 is to 16. The two ratios are different. Hence, in such cases where an element exists in the form of different isotopes, the law of definite proportions will not hold good. Carbon dioxide, which is having C12 isotope in one case and C14 isotope in another case, will not obey. So in such cases, the ratio between the elements will not be the same. Question number 9. Four statements are given which pertain to a chemical equation. Choose the correct statement. A. A chemical equation. It stands for chemical equation. It conveys only qualitative aspects of the reaction and not the quantitative facts of the reaction. B. It may be represented in terms of ions and electrons participating in the reaction. C. It need not represent a true chemical change. D. In case of gaseous reactants and products, a chemical equation gives no idea about volumes of substances involved in the reaction. So, out of these four options, which one is correct? If you look at these options, option B is correct. What does it say? A chemical equation may be represented in terms of ions and electrons participating in the reaction, meaning in the way a chemical equation is represented need not always be in terms of molecules or atoms participating in the reaction. They can also be written in the form of ions instead of the whole molecule. If the compound is an electrovalent compound, it can be represented in the form of ion. Thereby, exchange of electrons can be shown. So, you will have an equation in which the reactants and products are represented as ions and also electrons which participate in the reaction. So, statement B is correct. Statement A, why is it wrong? A chemical equation conveys only qualitative aspects of the reaction and not the quantitative facts of the reaction. What does it mean? It means that from a chemical equation we get to know what is the reactant, whether it is carbon dioxide or whether it is methane or if it is ammonia, that's all. And what is the product form, what are the compounds, what are the elements formed during the chemical reaction. No, that is not the case. A balanced stoichiometric equation gives full quantitative facts of the reaction. how many moles of the reactants are participating, how many moles of the products are formed, how many molecules of the reactants are participating, 2, 3, 4 of one compound, the other compound, etc. And also the number of moles of the products which are formed. So, quantitative facts relate to number of moles or number of gram atoms or volumes, even volumes of gaseous reactants and products. The information is given under quantitative aspects of a chemical reaction. So, first statement is not correct. What about C? It need not represent a true chemical change. Whenever a chemical reaction occurs, only then you write a chemical equation. You don't write a chemical equation for a reaction which is non-existent, which does not take place at all. So, it need not represent a true chemical change is wrong. What does it mean? Any any reaction which is not taking place also can be represented by a chemical equation, which is incorrect. We generally, in essence, what does it mean? We generally write a chemical equation for a chemical reaction which is occurring. D. In case of gaseous reactants and products, a chemical equation gives no idea about the volumes of substances involved. That is also incorrect. In case of gaseous reactants and products, from the number of moles of participating reactants and products, the same can be given in terms of volumes of gaseous reactants and products. So, among these four statements, statement B is the correct one. Here I have shown two chemical reactions which are taking place. That is, first one is zinc reacting with dilute HCl to form hydrogen gas, and zinc chloride compound is remaining in the solution. You can actually measure the volume of hydrogen gas which is liberated when a definite amount of zinc metal is reacted with dilute HCl. The next experiment which I have showed is electrolysis of water, wherein when you pass electric current through water, decomposition of water containing a little amount of acid to make it a conductor. So, decomposition of water occurs with oxygen gas liberated at the anode and hydrogen gas liberated at the cathode. Experimentally, you can measure if the gas jars in which the two gases are collected is graduated. You can actually measure experimentally the volumes of oxygen and hydrogen gases which are evolved. So, once we write a chemical equation, it gives exact information, both qualitative and quantitative information about a chemical equation. In this slide, I have given the relationships between mass, mole, and Avogadro number. It's a schematic representation. Mass of an atom or mass of a molecule, the number of moles, and Avogadro number. And beside it, I have also given the mole conversion diagram, how moles can be converted to gram mass or gram atomic mass or molar mass. The whole thing I have summarized in the next slide. The mathematical relationship between mole, atomic mass, molecular mass, which is also called as molar mass. You can use the term molar mass, Avogadro number, and molar volume at STP. It is summarized and given below. If you study this thoroughly, you will be able to answer any numerical based on mole concept or molar mass, atomic mass, etc. 1 mole of atoms, what is it equal to? Na, Avogadro number of atoms, 6.022 into 10 power 23. That is Avogadro number. 6.022 10 power 23 atoms is equal to 1 mole of atoms. And what is the weight of 6.022 into 10 power 23 atoms? The atomic mass of the element in grams. Atomic mass of the element in grams. That is equal to the mass of 1 mole of atoms, or in other words, Avogadro number of atoms. Second, how to find out number of moles of atoms. This you have done in the problems also. Mass of the element taken divided by its atomic mass. I don't have to tell further about that. Third, how to calculate mass of one atom of an element, that is its atomic mass divided by 6.022 into 10 power 23. Why? Because 6.022 into 10 power 23 atoms of that element will weigh its atomic mass. For example, 6.022 into 10 power 23 atoms of sodium, Na, sodium, will weigh 23 grams. Therefore, the mass of one atom of sodium would be its atomic mass 23 divided by Avogadro number 6.022 into 10 power 23. Similarly, 1 mole of molecules means 6.022. It's a collection of 6.022 into 10 power 23 molecules. And what is the mass of it? That is equal to molar mass of the compound in grams. For example, if I take 1 mole of carbon dioxide molecules, it will have 6.022 into 10 power 23 molecules, a very huge number of molecules. 1 mole of carbon dioxide is equal to 6.022 into 10 power 23 carbon dioxide molecules. And what is its mass? Its molar mass or molecular mass is equal to 44 grams. Molar mass expressed in grams. Then, number of moles of a compound, you know how to calculate. Compound means it exists in the form of a molecule. Mass of the compound divided by its molar mass or molecular mass. How to calculate mass of one molecule? Mass of one molecule of any compound is equal to its molar mass in grams divided by 6.022 into 10 power 23. For example, what is the mass of one molecule of water? We know that the molecular mass of H2O, water, is 18 grams. So 18 grams divided by 6.022 into 10 power 23. That would be the mass of one molecule of water. 18 divided by 6.022 into 10 power 23 grams. It would be a very, very small quantity. Next, one more important relationship is with the volume. If the reactants and products are in the form of gases, we can have a relation between their volumes. So, volume of 1 mole of a gas or volume occupied by 1 mole of a gas at STP under standard temperature and pressure is always found to be 22.4 liters or 22,400 ml or cc. This is also an experimental fact. Volume occupied by 1 mole of, say, carbon dioxide gas at STP is 22.4 liters or 22,400 ml. Volume occupied by 1 mole of methane gas, CH4 gas. Methane is CH4, carbon 12 plus hydrogen 4, 16. So 16 grams of this gas, methane, CH4 gas, 1 mole of gas at STP. This gas would occupy a volume equal to 22.4 liters or 22,400 ml. So, some more questions are to be given that I would post in the next, slot, next module. So, till then, please go through whatever I have given.